Hello and welcome to JavaScript Marathon, a full day of free online courses in some of the leading web development technologies and concepts. I'm Sarah Renaud with this.labs, and I will be your marathon host. Before we get started, we want to send a big shout out to our sponsor today, Syncfusion. If you're looking for a UI component suite, you should check out their Essential Studio platform. It includes over 16,000 components that were built from scratch with performance in mind. They're lightweight and modular. The platform is really user-friendly and devs find it quick to learn. It offers pixel-perfect built-in themes that are available in Material, Bootstrap, and Fabric designs, and an accessible high-contrast theme. Which, speaking of accessibility, all Syncfusion controls are touch-friendly and render across desktops, phones, tablets, which makes it a great tool for those using adaptive technologies. So if you want to make your devs' lives easier, and you're working with JavaScript, JS frameworks, ASP.NET, Flutter, Blazor, just to name a few, I definitely recommend checking out Syncfusion by visiting syncfusion.com. A ton of upcoming events here at this.labs. We have State of Angular is live next week, Thursday, April 1st. We also have GraphQL Contributor Days coming up on April 13th. Modern Web is back with State of Application Monitoring on April 20th. And our Women in Tech Monthly Mentoring returns on April 21st. For more information, subscribe to our newsletter, The Lowdown, for weekly updates, or follow us on Twitter at this.labs. JavaScript Marathon is back in May. We have another round of incredible sessions with experts in the dev community coming back on May 19th. Stay tuned for updates at javascriptmarathon.com. Our next session is brought to you by Dustin Goodman, Engineering Manager at this.labs. Welcome to JavaScript Marathon, Dustin.
Hey, thanks for having me. I'm really excited to be here.
You can find Dustin on Twitter at Dustin S. Goodman. Dustin will be presenting Migrating from REST to GraphQL, and I will let him take it from here.
Thanks, Sarah. Well, welcome to Migrating from REST to GraphQL. We're going to talk kind of about what it takes to get from a existing REST API that you've been building for years to a fancy new GraphQL one. And hopefully by leveraging your existing API, that way you don't have to go rebuild your entire ecosystem, which is a lot of people's holdup in doing this migration. So before we kind of get into the specifics of like how everything's going to work, I want to talk a little bit about how GraphQL is going to help us in dealing with some of the pitfalls. So first off, GraphQL, it's amazing. It is a query language for your API. It makes it so you can see exactly what you're getting out of your request when you make it. So for starters here on the left, I got a user query and I want their ID, name, email, and role. And on the right, you can see GraphQL is going to give me exactly what I want. It's going to tell me those fields in that order, in that space. It makes it really easy to get the data I want. The next issue with REST is the issue of underfetching. So when I'm, writing my API and I'm doing some data fetching, I sometimes need more things. So in our demo today, I'm going to be showing you a character API with locations, and you're going to see that one of my issues is going to be to get locations and characters together. I have to get my characters, and then I have to make a second request to go get my locations. And sometimes that looks a little bit kind of like this, where on the left here, I have my old REST API. It just tells me name, email, role. And then on the right here, I have the comments for that user. And I had to make 2 requests just to do that. Kind of a pain. A lot of slowness on the front end for your clients, and definitely something you want to avoid. In GraphQL, we can do it all in a single execution. So I kind of combine my user request with my comments, and all of a sudden I have one single request with exactly what I want. The other side of the coin is overfetching. Sometimes you build your API in such a way that it's just going to get way too much data. In this case, we don't need certain fields when we're trying to do certain displays, and we're going to show that during the demonstration today as well. So GraphQL's solution to the problem is kind of the opposite of REST again. So here, this is a user doc. It has comments, posts, created at, last updated at. We don't really need any of that. So instead, we switch our request around, and all of a sudden, all we have are the exact fields that we want. Another classic REST API issue is the all or nothing issue. In REST, you make your request, you either get an error or you get data. Kind of a really bad experience for your users. You sometimes want to actually show them something, even if you weren't able to get all the data. So, for example, I have this request here where I grab a user and I try to get their comments. And on the back end, what's happening is we have the user request was successful, but then the user comments fails on the back end, and it results in either a 500 or maybe it was a 400, kind of depending on what your implementation was. In GraphQL world, though, in the same scenario, let's say comments failed with a 500. Instead, what we get is a nice big user response with no comments. It's been nulled out. And then we find out, hey, what errors were happening along the way? And then my favorite issue with GraphQL that it solves is batching, especially with big dashboards. Sometimes you need to request a bunch of data from a bunch of different APIs just to populate a single page. GraphQL is awesome in that it allows you to request from all those different resources in a single call. So before, let's say we needed a user, their sales data, and their marketing data, we had to make all three of these requests. Now in GraphQL natively, it just lets us make all three requests in a single call. Super easy to do. Again, we'll show a nice little example of that in a little bit. So let's actually talk about the migration. I have a repo set up, and somebody's going to post it into the chat for you just in a second. But if y'all want to play along at home, everything is in pull request form. You can kind of see where I'm going with everything. And to show you what we're building today is a Rick and Morty API. I really love the show, so I thought, why not? Let's build some data around it. So what we're going to do today is I want to add location information to each of these characters. What dimension are they in, and where are they from originally? And right now, this is a React application powered strictly by a REST API. And our REST API looks a little bit like this guy right here. So each character has a bunch of information about them. And if you kind of look back at our data over here, you'll see we're only showing a few of those fields. So the data and what I need are going to be a bit different, and that's where we're going to start today. And I'm going to pull a single record up just for simplicity's sake. And we're going to go by kind of looking at our API and starting to build out the GraphQL. Now, I've built this in Express because it's a lot easier to do it, and I'm not using Apollo, which I'll talk about a little bit later, because I know some people are here who love Apollo and are really excited about using them there every day, but sometimes you just don't have the flexibility of using that. So let's talk about what I have set up here. In Express, I have my legacy API, which you can see through my routing. I have a very simple find all request, takes in the request, parses some pagination information, collects some character information as well as the pagination info that I need to send out, bundles my request, and sends it out to the client. So I need to replicate a lot of this into my GraphQL API today. So what am I going to do? So in GraphQL, I have my types and I have my resolvers. I'm going to skip kind of the GraphQL basics, kind of make that assumption. If you have any questions, though, along the way, definitely feel free to post in the chat. I will do my best to answer. So given our schema here, I have kind of my type definitions here, just kind of set up some basics, and I have some resolvers here, again, set up some basics. Showing you what this looks like, we have in Graphql, which is a really great way to test your queries and highly recommend using it on any project. I've set up my kind of basic hello world query, as everybody should, just to make sure that GraphQL is hooked up correctly. And as you can see, works just fine. If I try to put any subfield selectors on hello, it's going to be like, hey, I don't know what I'm doing. That data doesn't exist whatsoever. If you're ever curious what your schema looks like, there's a documentation explorer. You can look into your query and you can see hello just returns a scalar string, which is my case here. So gonna just back all that out, go back, and we can see our queries working just fine. Raphael asked, very roughly, what is a resolver? A resolver is going to be something we're going to talk about a lot today, but it's how you're going to get your data from your backend system into the GraphQL schema language. It's going to be very interesting to see how this works, and we're going to actually go build our first couple resolvers right now. Starting with the character one. So first we have to define our type. And in this case, I'm going to go to our type definitions here. I'm going to make a new file that I'm going to call character. And we're going to go ahead and generate this. And we need to kind of come up with what is a character. I'm also going to go ahead and, while I'm here, register character along with what I'm doing, just so it's available. And I'm going to start off by importing the GraphQL template helper. This is just going to make it so we can do a lot of really nice GraphQL syntax without having to reinvent the full wheel. So first off, here's the character type def. And this is just going to look a little bit like this. It's a simple template string, but the GraphQL tag gives us some syntax highlighting, which is very helpful as I'm going to be typing this up. So first things first is we need to define what is a character. So first, we're going to say we have a type that's called character, and we're going to give it some very helpful fields. First off is going to be ID. A character has to have its identifier, and we're going to set it to be a required GraphQL field because every character must have an ID. And then for the rest of the data, we kind of actually got to go look at our REST request and see what is available. So I'm going to, create a quick comment and paste our data just so we can see the general structure of an existing character. So first off, they have a name. That's super helpful. I'm going to go ahead and just set that to a string, make that required. Next, what I'm going to do is we have the image. Let's go ahead and pull that in. Image, we're going to call that a URL. And URL is a non-standard GraphQL type. I pulled in a library called GraphQL Scalars and really appreciate how it works. It gives us some great validation. So I'm going to go ahead and use that. I'm not going to make it required because maybe I don't have an image for certain characters. Next, I'm going to set up gender. That's going to be a string for now, but I think maybe we can do something fancier with it in a minute. Next, let's go ahead and get that. We're going to skip location and origin for now because we don't have a location type defined yet. And I'll show y'all what we're going to do with that in a little bit. But for now, let's go ahead and add the status in. That's going to be a string, and species is also going to be a string. I should not typo anything, though, along the way. There's also this type. I'm going to stick that in there. It looks like it might have a value. It might not have a value. So let's go ahead and just make that a string for now. And I'm going to skip created and updated at because I don't think they need to be exposed through our API at all. So went ahead and created our character type. And this is super helpful because now we can start talking about characters in our API. I'm going to add a few other types, though, because looking at our original request here, this is a paginated request, and you can see we have an array of data, and then we have a bunch of nodes, a bunch of pagination data. So I'm going to go ahead in here, and I'm going to make kind of that same structure because we're going to need it for our character query itself. We're going to call it a character connection. And in here, I'm going to set it up to have some nodes, which are going to be an array of characters. And then the page info. I don't have this defined yet, so I'm going to just call this JSON for now, which is a total bad practice. You should not do this in GraphQL. I'm going to go fix that momentarily, but something I needed to set up. And then finally, I'm going to set up the queries. So for this API, I need probably two queries. One is going to be characters. And in this case, what I can do is in the pagination, I could take in some inputs. Again, I don't have this defined yet, so I'm going to leave that out for now, but we'll come back to it. And then next, I'm going to add the character connection. And then on the other query, what we're going to have is a character, because sometimes you want to just get one object. And we're going to set that to a character query that requires ID, and it's going to return that single character object. So now we have our nice little schema here defined. And what I'm going to do at the end is I'm just going to export this data. And now it's going to be registered in our API. So if I go back to Graphql, we're going to see I have this character query kind of set up to handle some of this data now. although it takes in some features that I haven't quite prepared yet. So let's go ahead and try and run this. Let's also comment out the pieces that aren't ready and see if we can actually query. And it has no subselections and the whole thing's not working right now. So let's comment out page info as well for now. See, are we getting any data? And what we're seeing is, hey, there's no data being returned. And that's where the resolver is going to come in. And that's going to be our next step. So now if I go in back to my code, what I'm going to do is I'm going to establish our first resolver here. So here's our index file. We're going to go ahead and make a new character resolvers file. Naming convention aside, this is the one I chose to go with. Any naming function of your choice will work just fine though. So we're going to set up these resolvers as an object and just going to go ahead and set it as an export. And first thing we're going to do is we need to define, like our schema, the resolver for each of our different queries. So if we go back, we see, if we go back all the way to our character file, we see we set up two different queries, one for characters, one for character. So now we need to set up those different query-based resolvers. So the way that this tool is going to work is it's going to let me, I'm using the, I'm trying to remember the name of this tool, actually. Let's open the right package JSON. We're using the GraphQL tools library to generate our schema dynamically, which makes life a lot easier, gives us a lot nicer, prettier syntaxes, structures things very easily. So now that I'm using that, I'm going to try to structure this file to be almost identical to the character. So type query characters and character. So in here, what I'm going to do is I'm going to go ahead and set up characters as one of my resolvers, which is going to take an async function. And I'm going to set up character, which is also going to take an async function. Now, I'm going to start with the characters implementation because I think that's a little easier to start with. And the way this is going to work is every GraphQL resolver takes in three fields. The parent value, the arguments, and then the context. I'm probably not going to use those right now, but we might find that we need them later, and I'll show you in the character one specifically how we'll use some of that. So now what I can do is I can make a request to my old REST API to actually populate the data here. Now, there's some other fancy tools that some of you may be familiar with, but we're going to use just fancy old fetch API. It just makes life a lot easier for the sake of this example. But you definitely do this with something like Apollo's data REST sources. Very useful tool for doing exactly this migration, but it was a little overkill, and I'm not using Apollo in this project, so it wasn't helpful to me. So now what I'm going to do, I'm going to set up my requests to my old API, which I'm going to do a bad and just hard code some values around for now. These should really come from environment variables, but I didn't set that up for this project, so I apologize. Y'all are getting this version of the solution. Now what I'm going to do is I'm going to follow just kind of the API pattern and get out exactly the data I need using fetch's implementation. And then at the end, I'm just going to return that data. So if I did this right, hopefully what's happening is I'm going to get exactly the same request body back that I initially made for the REST API, but now I can use it in my GraphQL schema. So if I come back and I run the same query, it is still null because I forgot something, I'm sure. Let's see what's going on here. So the data is coming back as, maybe let's restart our server. Who knows? That's always a good little trick. What didn't I do, everybody? I didn't register my resolver. That's what happened. So we're going to go ahead and we're going to just require our resolver here. And hopefully that's going to change the entire behavior of everything we were just seeing. And sure enough, that's exactly what happened. Now we're getting kind of a structure here, but our issue is, hey, nodes is null. If we go back to our data here, like I wrote, got my console output here, and we can see that the actual object is going to return what I'm calling nodes as data. So what we need to do is go back to our resolver here and just do a little destructure magic. So what I'm going to do here is we're going to have data and we're going to have page info. And I'm just going to return those in a reshaped way of data and page info. And hopefully when I go back to my API now, what we can see is I missed something yet again. What did I miss this time? Always fun when your demos don't work, right? Let us find out very quickly what happened here. Let's add data and let's add page info. And let's run our request one more time. And data is in, aha, it's data. Wait, that doesn't look right. There we go. Data should be in my array. What am I not returning? Nodes? Nodes. Spelling matters. Okay, so there we go. Now we have a working GraphQL API with live data that is using our pre-existing REST API to populate all the data already. Now, kind of the next step is we need to do some of that pagination I mentioned. So I'm going to cheat a little bit and borrow some code that I've already written, but I'll walk you through it, of course. So this is going to be a pagination file that I created. And what we have here is we're establishing a few new types. The first one is going to be this page info type. So I mentioned earlier that we're going to get some page information back from our request and we need to display it to a user, but we want to define it so we can actually show it in our schema. And what we have here is we're going to have page, per page, total pages, and the total amount of objects. Every API implementation is going to be a little different and different people want to show different data. So we want to make sure they have all of that available. The next thing I've defined is a new input type. This lets me define what type of data my request can take in through the arguments. So in this case, this is a pagination object that takes in page, per page, and a sort direction, where sort direction is a enumerable type defined as either ascending or descending. And now what I can do is once this gets registered as part of my schema, so I'm going to come back in here, I'm going to go ahead and just register pagination along with character. I can go back to my character type definition and change our bad JSON implementation to page info. And I can actually now do our implementation from earlier that I mentioned, where we have a pagination object, and this can now be of type page info. Not page info, I called it pagination input. So let's go ahead and set that up. And then to get pagination fully working, what I need to do is I need to go into the resolver now and actually get that data. So I'm going to go ahead and just show what the arguments look like now that I've had time to implement the inputs. And going back to Playground real quick, I'm going to go ahead and re-enable some of the things that I disabled from earlier. So first off, the page info. And secondly, we're going to grab this pagination object. And for context, we see there's 20 objects. Let's go ahead and just narrow this down to the first page, and let's make it 3 objects. And if I try to make this request now, we're going to see that I'm getting the same exact results back, but I am getting the page information now. Now, why am I not getting it? Well, it's because I didn't pass along any of the page information to my API. So if we go back to the log statement that I made earlier, where I get the actual pagination object, and let's go ahead and remove this console log so it doesn't interfere with us in the future. What we can see is this pagination object has, or this arguments object has a pagination object. It has 2 fields, page and per page. And what's really nice about this is I can now just pull out the pagination object. And then in here, where I have my arguments, I can get the page and the per page out of said pagination object, if I can type today. Now what we need to do is, with all of the pagination data that we have, we want to make sure we can go ahead and pass it along to our old REST API. If we go back and kind of look at what find all looked like originally, it takes in a query parameter for page and another query parameter for per page. If neither exists, it defaults to certain values, which is where the 20 was coming from. And then it goes ahead and queries our database and returns that data. So we want to do the same thing. Now, what's different between GraphQL and REST, and another great advantage, is because page and per page are defined types, what we have now are a way to just pull these out and know that they're already going to be casted to the correct type. So because page and per page are defined as integers, I have integers and I don't need to make sure that they're not strings instead. GraphQL does all that validation for me up front. So I'm going to go ahead and update my request here to match what our implementation was on the other side. So we get the per page and $ per page. And assuming I didn't mess anything else up this time around, if I go make my new request, I only get the 3 objects I requested and nothing else and nothing more. So at this point, we've completely leveraged our existing API to do everything in GraphQL, which is super helpful and great. And that lets us build our backend. But what about our front end? And that's the next part I kind of want to show a little bit of. So I'm going to go ahead and do a little bit of cheating here. I have gone and done all of these steps as their own checkouts. Let's go ahead and just do it the hard way. So showing you the full implementation that I did ahead of time, I made a few additional changes. First off is you'll see character has some resolved fields. Specifically, what I've changed here is in character, I've actually made gender and status enumerables as well, and they need to be casted to specific values. So I have my enums defined here, and I've gone ahead and established them as one of the defined values that are allowed in these specific fields. And then I've renamed image to avatar. And I did that just because I decided when I was building this, I wanted image to be called avatar instead. It's more clear to the UI. So if I come back to Graphql, once I actually restart my server, we can absolutely see all of the different features that I just mentioned. We can see our full API, and we can see all the different fields that we made available. I didn't put any documentation in. That's on me. But it's very simple to update your API with a simple, here is a doc string for this type. And if I come back now to my query and my character, we'll see that we can add quick documentation and inform our users of what does this field represent? What is this data? And it's very valuable to see that to them. So if I keep going down this route, we can see that our characters work exactly as they were, and we also have a character implementation as well that is fully utilizing our existing APIs. So both using the old fetch API, working just great. So moving on to kind of the front end side of things, I'm gonna go ahead and just close these out. I have a Next.js server that I've built with React. And in here, what we can see is we have a character API that has just your classic fetch. And then I have a component a little further upstream called character list data, that has my GraphQL query happening. And I've done this all with React query. If you're not familiar with it, I highly recommend going and reading up on it, but it's a great way to utilize both REST and GraphQL APIs in the same application while using the same hooks and destructuring allowed. React query is great because it allows you to do both any type of REST or protocol available on the internet and send it all through these single hook points. So what I've done to abstract here is I've made a function called getAll that's coming from this character API, which is just a simple fetch. Now, what I'm going to do to get this working, I'm going to kill my server real quick. I actually need a new package called GraphQL request. which is a really nice wrapper around the fetch API, specifically for doing GraphQL requests through React Query. So highly recommend. And I'm just going to go ahead and get the server back up. And what we're going to do is we're going to just change this layer right here, the character API, to allow for the fields we need. So first and foremost, we're going to go ahead and establish some environment variables. In here, you can see I have a GraphQL API URL that'll make it a lot more helpful for me. So I'm going to go ahead and, oops, wrong file. Come in here and establish that value. I'm also going to come and import the request and also GraphQL tags from the GraphQL request library. Why are you mad at me? What did I fat finger? I fat fingered something. Let's go ahead and paste from elsewhere. Okay, so we have all this going. And so what I'm going to do now, oh, Keith asked, if you have an app that uses mixed REST and GraphQL endpoints, would you recommend using React Query over Apollo with their REST link? Ooh, great question, Keith. Miss you too, buddy. I love React Query. It is a fantastic utility library. I also love Apollo. It has a lot of other fantastic features, such as its normalized cache. I think it depends on your project. For something small like this application I have here, React Query is a fantastic tool. If you're starting to bootstrap a new application, I would actually suggest React Query at first. And as you find you need to start optimizing and managing state a little differently, Apollo could be a great way to resolve some of those issues. So I'm gonna edge people towards React Query because it's also hook based, and I'm not as familiar with Apollo's REST link. But if I remember correctly, it's not hook based yet, and that makes it a little more challenging to use. So coming back to our example here, let's switch our REST API now to actually use our GraphQL API. And the way I'm going to do this is we're going to just set up a new response, which is going to use the GraphQL request object. And we're going to set it first to use the URL that it needs to point to, which is our GraphQL API. Then the document that we need to send. So that's where I'm going to use that GraphQL tag. And just like our backend, I can now shape my query. And what we're going to do is we're going to call the characters API, and we're going to establish some variables that we could pass that we're going to establish very similarly to what the backend looked like. And then in here, what we're going to do is we're going to make a request for characters. We're going to pass in that object straight into our request. And then we're going to request out the data we need strictly to show the page that we had. So if we go back to our page before I hit save, we're going to see we need the name. Oop, hello, refresh. We're going to need the name, probably the ID, their status, their species, and their image. So let's go ahead and establish that. And what we can find is I need ID, avatar, name, status, and species, like I just said. And then for the page info, I know that I actually need the total pages for my pagination utility here. So next thing's next, we're going to go ahead and set up a new input object here so we can actually replace our variables dynamically. And the first one I'm going to do is page, and the second one I'm going to do is going to be per page, and I'm just going to set this to 10 because I decided I want to reduce the number, actually 9, because I want to reduce the number of objects on the page. And then as far as the page itself, that should be coming from the other requests because I put this all in the wrong place. Apologies. Let's just move that down into the function I intended to put it in, and know that page is actually a parameter into this function that we can use and pass along to our server. I hard-coded the 9. You can change that on a per object basis. And then the one thing I need to change here would be response characters. The the reason I need to change this is because GraphQL is going to wrap our response object a little differently than it did originally. So if we go back to our characters example, we'll see that nodes and page info are now down a layer underneath this characters, whereas in our original request, we had data at the top level, and then this changed it just a little bit. So to keep our API consistent, we're going to change it to characters. Reload, not show that window because that wasn't the window I meant to show, and come back to our API, refresh, and what we should see is we have an issue. And the issue is probably around the fact that I didn't make some changes to our data layer. So one of the key things with React Query is use query is different behaviorally pending if you're using a REST API or a GraphQL API. And the main difference is this is loading key becomes is fetching. So I'm going to go ahead and make that change real quick. And we're going to refresh again. And hopefully we see something working. Again, we're seeing an issue. Probably because what's happening is data here is actually the nodes we want and not data. So we're going to go ahead and change that. Refresh again. And hopefully this time we actually see data again. And the thing we're going to notice is all my images just disappeared on me. So what happened? How do I get my images back? I have two options at this point. First is I go into my character list. I find that there's actually a character card, and I change the image URL to actually be avatar now. Or I can leverage some of GraphQL's amazingness and go ahead and just rename it in my query from image to from avatar to image. And the way you do that is you specify what you want it to be as its alias. So if I come back now and refresh, hey, we got a bunch of images again, and we can see all of our data is back. So everything is working now. We're in great shape. Everything is starting to work again, and we're very happy people. So what's next? Next thing that we might consider is rewriting our API layer to actually use our existing database connections and actually get the REST layer out of the backend. And the reason we kind of want to get the REST layer out of the backend is it's going to add some slowness to our entire system. Now, that's in the case of my application. This is a very simple monolithic Express application. If you were working in a microservice architecture, you would use the protocol that most makes sense for communicating between your GraphQL service and your existing microservices out in the ecosystem. On a previous project, we used the serverless framework for AWS. It's just the serverless framework. We used it on AWS. And the way we established it is we had a GraphQL service that then used the AWS SDK Lambda request to request from different Lambda services that we had deployed. And it kind of made it so each service could stand alone as its own REST API. And then our central GraphQL service just allowed us to leverage all of that existing data, tie it together, and create a single endpoint for our client consumers. So that's one strategy for kind of building out a microservice version of this. But if you're in a monolithic application like this, I would recommend actually changing your resolvers to use your database a little more, directly. I see a couple questions. I'm going to answer those real quick. First is from Raphael. Question unrelated from the front end. While departing from REST to GraphQL, is there anything on GraphQL that replaces REST? I don't know what that word is, but discoverability features. Are you talking about, if you're referring to the options, that's where the schema request comes from, and that's how we can view kind of our full schema and the discoverability of like what queries exist in our API and how that is visible to the user. I'm not entirely sure if that answers your question, though. I would love more clarification. And then Maria is asking, when would it be appropriate to use data loaders? Data loaders are going to be a more prominent example in a little bit. So give me a few to show you that. It's coming. Okay, so oh, I did answer the question. Woohoo. Um, moving right along, we're gonna go ahead and now change our resolver implementation, like I showed before. So coming back, closing up our client, opening up our server, going back to our routes, we have our GraphQL character resolvers. And we see both of them are just using the same code that was used inside of our character route here. So option one is quite simply, let's copy and paste everything and just tie it all together and make it work. That's one solution and definitely one you could take. If you want to still support your legacy REST API though, and you also want to build features that work on both REST and GraphQL, something I recommend instead is doing something a little similar to this, which is creating what I call a BL directory, which is business logic. And in here, what you could start doing is adding a bunch of new um, BL functions, character, that handle all the different API interactions. So specifically, all of this functionality in here is great. Specifically, this piece of the puzzle, like uh, how I fetch my characters and return them back to the API. So what I'm going to do is I'm going to go ahead and in here, I'm going to create a new exports. We're going to call it getAll. And I'm going to make a new function, getAll. That's just going to be an asynchronous function that takes in two parameters, page and per page. And what I'm going to do is I'm going to borrow a lot of my existing code from my existing find all because I don't want to rewrite everything. It's no fun to rewrite stuff when it's unnecessary. And then let's just make sure we're in the right layer because this is where I always get in trouble. All right, so we're going to have our characters. They're getting pulled from our models. Our models now have characters and our character count, which need to come from this page and per page value, which let's go ahead and set our defaults here. Page is always going to be 1 by default and 20 by default. That way we always have some data. And then what we're going to do is we're also going to grab this response object that came from our original character API. And we're just going to make sure that this is our return object for our function. Let's go ahead and just make sure everything's aligned, and it is. So in our export here, let's just make sure that character is our main one. So character, I'm going to call it character BL. Character BL equals require character, and that way it's now exported and I can use it. And so now we have all of our characters available through this function. And what I can do now is rewrite this function here to simply be a BL function. So I can go and get my character BL from my business logic layer. And what I can do is I can just call my data is going to be awaiting the response of character BL getAll, and we're going to pass in page and per page from above, and then we can go ahead and just delete a lot of things, and then delete a lot more things, and all of a sudden what we should see, or I hope we see, is that our API hasn't changed at all. Everything's still super friendly and reusable. But now what we can do is in our character layer, we can go ahead and replace all of this business logic with the new business logic that I just wrote. So going in and doing the same changes. Oops, a little fat fingering. So we get our BL, and now what we can do is if we get our data again, it's going to be awaiting that same character BL getAll, and this time our page and per page are going to be coming from our GraphQL layer per page. And then the one thing we might need to do though that's a little different is if we look back at our implementation here in our BL, what we see is we return it as data and page info. So what we might want to do instead is do a quick destructure to get data and page info. That way, when we do our return, we can go ahead and do a remap right here in the response. And assuming I didn't mess anything up along the way here, what we'll see is now we have shareable resolver code between our REST API and our GraphQL API, and we didn't have to change a whole lot of code. Separates things in a way that makes it a lot more testable, which is always an ideal, and makes it so we can build out a lot of this really cool functionality kind of as we go along our way. So that's been kind of the main part here. So the last kind of thing I want to really show, excuse me, is going to be how we get from characters now to that location info that I talked about previously. And Maria, I want you to pay attention because this is where some of that data fetcher is going to come in. I'm not showing data loaders today, but I'm going to point out where it's relevant. So in our type def here, what we're going to do is we're going to go ahead and add a new one for character, or sorry, not character, location. And I'm going to go ahead and cheat ahead a little bit because I don't want to write all of my location code yet again, but it's going to look a lot like our character one where we had a location, ID, dimension, name, type, and all this is going to be available through our API in the same way that character data was. And what I want to do next, let's see, let's go ahead and get location registered. Location, I should learn to spell. Location. And now the type definition is defined, but we have no resolvers whatsoever. So we can't actually get data into our GraphQL yet. Keyword yet. We're gonna make it real fancy and get it working in just a moment here. So in our resolvers, we need to go ahead, register location, just like we did character. And for our resolver, what we're gonna do is we're gonna go ahead and I'm gonna cheat a little bit and borrow some resolver code I already wrote ahead of time. Again, just to save a little bit of time so we can get to the meat of what I really want to show today. But as you can see, similarly to how I did characters, except this time I copied and pasted all of my logic over here, we're going to have a nice little layer that connects directly to our database. So this is if I never had that REST API for location, I created a brand new location resolver directly on our database. But what we're going to find is there's going to be a problem with this very shortly. So let me go ahead and go to my GraphQL layer here and just kind of show off the fact that I have locations working, kind of just proving that I did a thing. So here we go. We got some working things, including the ever so popular Anatomy Park. I absolutely recommend the Pirates of the Pancreas if you've never had the chance. But now we have our locations resolver, and now we've got locations defined as a type. I know I skipped some steps here, but as you can see in our API here, we have locations. Here's the pagination input. It has a location connection. Nodes are a location type, and here are our defined types. Makes life a lot easier. So now that I have all that, I want to connect character and location. And that's kind of the next big chore on our to-do list for today. And so what I'm going to do here is inside of our character type definition. Earlier, I mentioned that we were going to do a new connection type. And I'm just quickly finding my notes so I don't forget how I did it. So we want to add two different things. One is going to be the current location. So where is this user? And the second one is going to be their origin, which is where were they located at the beginning of the series or the first time we met them. So going to go ahead and add those. And now I need to go to my character resolvers. And I need to now add current location as a resolver. character. And then I need to add, oops. Then I also need to add origin as a location. Character. And for now, we're just not going to return anything for either of these. But these are two things. I can't type, apparently. What did I miss? I missed an arrow. There we go. All right, so now we have location and attached to our character. Now, what's the problem here is I'm going to end up writing more or less the same exact function twice, which isn't ideal. And it's going to look a lot like in our locations resolver, the get location function that I wrote previously. So rather than doing that, I'm going to go ahead and come back to our BL. I'm going to write a location. I'm going to go ahead. I'm going to delete what I just did, and then I'm going to create a new get by ID, make it an async. It's going to take in an ID, and then we're going to pass in all of that logic I used before. The only thing I need to add to make this work 100% is get locations from our models equals require models. So now we should have this reusable get by ID. I'm not going to go update our existing resolver just due to time constraints, but we can definitely do that if people want to see it. But what I'm going to do now is I'm going to leverage our brand new resolver here to do a thing. So I'm going to go ahead and pull our location BL. And what I'm going to change is right here on these resolvers, how do I pass the ID into my BL function? So how does ID get pulled? Well, character has location ID, which is the current ID, and character also has origin ID. And I just want to use both of those. So what I'm going to do is I'm just going to point those to my location BL and get by, what did I call it again? Get by ID, which isn't going to work. And I see why. I will fix it in just a second. Location BL, get by ID, origin ID. So now we haven't repeated any code. We have a lot of reusability, which is super duper helpful. And what we need to fix is inside of our BL here, we need to make sure that we actually register the new location BL and not create a new file. Location BL again. Change this to location, and now it should be registered as a function called getById when I do this. All right, so now I should have a fully functioning API, and I should be able to pull character information now. So if I go back to our original character request here, you'll see current location is now defined. And when I ask for the current location name, we can go ahead and see that Earth replacement dimension is here. Now, Maria, here's the answer to your question. Now would be a great time for data loaders. As you can see, each one of these different nodes requested the same exact data. And if we go look at how my server was responding, you'll see I have 3 different requests to the same data element. So what I would do at this point is I would go pull up the GraphQL data loaders library, install it, and set it up so that when this resolver gets called, it prefetches and caches the result of that particular ID query and makes it so I don't have to go fetch that data iteratively 3 times over. So that's how data loaders is going to play into this equation. So we have all our new fancy data. It's hooked up to our backend. Now we want to just show it to our users. And with that, we're going to go ahead and go into our client one more time. We're going to go into our character API. We are going to add the new location information. So current location, and I'm going to add name here, and we're going to add origin. We're going to add name there. And what we're going to find is if I go into my character card. I kind of pre-sorted this already, but there's location information, and it's actually going to be current location. And in case it doesn't exist, let's go ahead and be type safe and set name. And when I go look at my page now, if I did everything 100% correctly, which very possible I didn't. What did I miss? I'm missing. Oh, haha! This was a bug that I wanted to show off. So remember that all or nothing thing I mentioned back when I had slides on the screen? This is GraphQL playing exactly into that. If we actually look into the request that was made, we'll actually see that all of this character data exists. However, for one of these characters, their location data just isn't available for whatever reason. And so we're getting all this data, but I, as the developer, did a thing where I decided I don't want to display anything if it's unavailable. So if I go to my character list data, you can see if any error occurred, I decided to just say, hey, an error occurred, render that instead of any of my feature, which is helpful to almost nobody. For speed of implementation, I'm going to go ahead and hide that. Excuse me. I'm going to go ahead and hide that. And what should happen, should be in the operative word here, everything should load just right, except that page info can't be found anymore. And page info can't be shown because I did something else and I don't understand. This is where we go check out other code, or I go fix something else. I'm going to go fix something else instead, which is going to be in that location BL. What we can do is we can choose whether or not to show our errors, our return error, I should say. Normally, you would want this to be true. I'm going to set it to false in a couple of cases, and return error, and return error. Whoop. Don't do that. Let's go ahead and go to my location resolvers and my character resolver. And we're just going to go ahead and set these to be false and false. And what I'm hoping happens is everything works itself out and I can refresh and we can go ahead and see that Rick's current location is his replacement dimension. And if we wanted to add the their origin or their home world, we could add that as the next step. Again, all this code's in the repo that I did, but I didn't want to. I'm running low on time to explain and show all that. So, and I want to make sure I answer any questions you all have. But that is kind of a demonstration of how you can leverage GraphQL to create new features, port your existing REST features into GraphQL, and then port them over using your existing source code. So we covered a lot. Couple things I would be remiss if I didn't share. React Query specifically doesn't have normalized cache, which is something that Apollo offers. And for those that don't know what Apollo is, it's a great suite of GraphQL tools for both the server and the client. I highly recommend both. And they're great, especially if you have rich, complex data. One of the things I really like about Apollo is instead of writing state mechanisms at my API layer, what I can do instead is leverage Apollo's native normalized cache to write queries into specific components, pass them just the ID that they need to render, and let them go refetch the fields or data they need and go back to the server. That way I'm not having to prefetch a lot of data that I may or may not be using. So yeah, that is pretty much everything I had.
Amazing, amazing talk, Dustin. You get an award, a JavaScript Marathon Award for efficiency in answering questions because you answered them all. So we don't have any questions at the moment, but if you're watching this on replay, go ahead and ask us some questions in the comments. You can also find Dustin on Twitter. I shared his handle in the chat as well, Dustin S. Goodman. Pretty easy. Thank you so much again, Dustin. This was an amazing session. We are back with Lindsay Wardell for our last session of the day at the top of the hour, 2 p.m. Pacific time, 5 p.m. Eastern time. So join us over there and have a great rest of your day. Have a good one, everyone.
Bye. Thanks for coming.